Okay, let's keep working on back this problem. The median of two sorted arrays. Last time I implement my solution, and at the end I noticed there's a problem, there's a bug for this case. Basically, that was I tried to get the start one, start two less than the target index. Target index uh, will be the size of array one, the size of two, uh, sum divided by two, the half one. And so I checked the mid plus one plus two, and there was plus two, since all both arrays are zero indexed. So made one plus made two plus two, that's the exactly length of the merged array. And when that one less than the target index, I will try to increase that made one, made two, based on different logic right here. And else if branch will be, if that length is greater than target index, I try to decrease that length, made one, made two. The final target will be I try to search in the made plus one plus made one plus made two plus two equals the target index. That's the target. But I notice when that case is true, we can't guarantee that one is the right position. Because back to here, because some cases when we do here, we maybe made one, that's made one. Made one and made two. So the problem is once we got made one plus made two equals the final target. And in that case, we can guarantee that's the right, partition, because sometimes we maybe need elder number from made two to add to merge into the final, array. So sometimes maybe this one is we need merge two, and we need this one made one move back one element. So that's the case we can't guarantee. So based on that problem, I just thinking to fixed problem. So basically, I'm thinking before I do the searching the right value, I just make sure I move the made one and made two to the right position. That means make sure all the left here and here are less than here on the right side, the minimum right side. So either one. So max is less than the right side minimum one. So in that case, we believe made one, made two plus two is the right length we got merged. But we can't make sure that sum made one plus made two plus two equals the target index. In that case, we could increase the made one or made two based on the different strategies. And in the new strategy, or combination, we had to adjust them to get the right number. Yes, right number, and see once we got the good, partition, we could compare the target index again. So that's basically the solution I saw to fix problem right here. So I need to rewrite all the implementation there. So go back to my console and open that one. Let's do the coding. So from top to the bottom, looks like all these variable declaration is good. The start is fine, end is fine, and the target is fine, made is fine. Okay, so I'm going to re-implement the while loop. So I'm thinking we could check while made 1. No. I thought I could use made 1 plus made 2 plus 2 when that equals the target index, but no, because like I said, we try to make a right partition to make sure the made 1 made 2 is right, so we need a search in the while loop. So for that end condition is not good. I'm thinking different conditions. What's the usually we could start use the condition and condition as the start 1 less the start and 1. Yeah. Start 1 less then and 1. And start 2 and then land 2. In that case, we need to check. So we also need to create a bool right partition. Okay, so we in here we just need 4 numbers. Numbers left 1, right 1, left 2, and right 2. Okay. If max left 1 and left 2 less, we just return max less I'm thinking if I need an equal, so if that's equal, yeah, that's fine. Equal, we could add equal right 1 and right 2. Okay, so if the max of left 2 elements less and equal than the minimum of right 2 elements, that is true. So while not true, right partition numbers 1 made 1 and the numbers 2 made 2 and the numbers okay. We also need to check detect the package for the end to the end of numbers. If that's reached to the end, yeah, if that to the end, let me check the constriction. Okay, so constraint the value is okay. That's minus. That's minus. I'm thinking how I could handle the package for that one. Okay, so in that case, we could handle the side case in the red partition here. So in that one, we do this. We change the input parameter for the, okay, for the numbers one. Input array, we need an input array right here. Numbers one, and input array numbers two. And integer made 1 and the integer made 2. Okay. Okay. So we also need a size. Let me do a calculation for that to see if no, not like this. We add size right here. Okay. Numbers one size and the integer numbers two size. Okay. If made 1 great equals then the number size minus 1, then and made 2 great equals number 2 size 1 minus 1. So lice. Okay, lice we return here, else if else made 1 greater equals numbers 1 size 1 and made 2 less than numbers 2 size 1 minus 1. We just return since made 1 numbers 1 made 1, numbers 2 made 2, and the numbers 1 made plus 1, and the numbers 2 made 2 plus 1. Okay, so else that means we don't need that's only 1, so let me finish this. I'm also thinking further for that. Maybe if we do that hell condition, we maybe do that out of this sub function. So that's not efficiency, but let me check first. So if converse, we just need 1 and 1. Yes, that else means made 1 greater equal than the size, made 2 greater equal than size, we just return true. Okay, so yeah, in that case we could call as is, but okay, let me do this for the clearer logic. So I'm going to optimization later on. So while right partition numbers 1, numbers 2, numbers 1 size, numbers 2 size, and made 1 and made 2. Okay, so while that's not true, we just check if made 1, made 2 both reach to the end, we already return 2, right? So we don't need okay, so in impossible case, since we search the median, okay, so but anyway, I leave that, so we don't handle both. We don't handle both made 1 and made 2 reach to the end of 2 arrays. Yeah, right here. So if made 1, we could copy this one, right? So greater than made 2, made 2, if made 1 greater, so we just in this case, in this logic, we try to moving 1 bit ahead. Here, 1 bit ahead to the 1 bit ahead to the from the smaller element. Yes. Else if that means we just need to made 2 plus pass. Else made 1 plus pass. Oh, I could do similar words, so let me do this. I could do made 1 less than numbers 1 size minus 1, and I'll do that later. So for the optimization, so while in that case we just searching. So to the end we write partition. So we just if made 1 plus made 2 plus 2, since 2 zero index array equals target index, then we do this. We just do this. If okay, so 1, 2, 4 line to the 1, 3, 3 line and paste right here. Okay. So once we reach there, I believe that's good right position, so we could do else. Here is tricky, so for the else, else means else else if less than target. Okay, so we just do this. I'm thinking if I need to do, we could just search in that one, right? So else else So that's the one. Should now reach here, so I will just return 0.0 as the exception. So I'm going to delete all the logic. In that case, we just searching around. Yep. Okay. That's the case. Okay, I think I finished coding. Let me run it on the Leetcode. Delete the old substring, and insert the whole, and run the code. Run partition. Do you mean float max? No. Do you mean made 2 in here? Okay, line 4. Yes, made 1 here. Okay, run again. Okay, it seems min and max is not support. Okay, let me do this. So int max nta and integer b, and just return if a equals b, just a and b. Int min b and a. Okay, let me run the example again. I got 0, 0, so something wrong here. Okay, let me print out here. So I'm going to print S1, S2, no S2, and 1, and made 1, target. Star 1, and 1, made 1, and the target index. Here we go. And write again. I don't have anyone. Okay, so start 1 is 0 less than, so the input 1 is 0, 1. Okay, hey. We go to echo for that one, and try to run it again. Zero one zero one 0 0 0 0 1 0 0 0 0. Okay. We don't stop loop. We don't stop loop because we can't find the one here. I'm checking, so the loop, I try to print out made 1, made 2, and write partition subfunctions. And made 2, I'm thinking, since that doesn't go this branch, that's only the quit, exit for this while loop, and that doesn't go out, so something wrong here. 0, 0, 0, 0, 0, 0. Okay, that's the right one. That's 2. So 0, 0 plus 2. 0, 0 plus that's 2. So 1, 2, 3. That's 1. It's greater than 1. Okay. It's greater than 1. So and 1 equals 1. And 2 equals 2. Then 0, 0. Still 0, 0. Okay. Okay, that's the 1. Okay, that's the. I think that's because this condition. So in that case, made 1 plus made 2 plus 2 is not right. I mean, if condition, since there's 0, 0. So we are searching 1. So the target index is 1, right? Is 1. So we're searching 1, but that like this 2. So how do I tile? So this condition, I need a new function. So let me create a new one to see if I could figure out. So the new one. So for example, the 1 array, 2 array. So once 0, 0 index made. Okay, made. 0, 0. So that should be 2, right? And 0, 1 should be 3. 1, 0 should be 3. That's right. So for the case 2, 3, we are searching the 1. Now I'm searching the 1 plus 1. Okay. That's right. So we are searching the target will be 2 plus 3. No. 1 plus 2 equals 3. That's 1. So first one we're searching 2. So 1 plus target plus 1. Okay, so 4, 4, that's 2. And we're searching 0, 1. Okay, 0, 1. 0, 1, 2, 3, we're searching 1. And no, we're searching 2. Okay, that's 2. Okay, another one. So 2, 3 is 4. It's 5. We got 2. So 0, 1, 2, 2, 3, 4. So we're searching 4. That's the right one. That's 1. That's 1. Okay. That's 1, right? 1 is 0, 1, 2. That's 1 is right. Okay, we're searching 2, 2, 2. We're searching 2, 2 back 1. And 2 is third one. Okay, that's right. And this is the 2, 2 plus 1 is third one. So basically we figure out the condition will be the made 1 plus made 2 plus 2, since that 2 array with 0 index equals the target plus 1. Okay, back to logic. So we're going to do this. For clear logic, I just do this one. Target index. Okay, let me try to run it again. Okay, that looks right. Now it's right. So we're searching 0, 1, 0, 2, 0, 1, 0, 2. Okay, we try to searching the second about 0, 0. Okay, so 0, 0. That means that's not right. So in that case, we need searching one more here. Okay, continue to debug. That we got that's wrong answer, and I try to figure out what's the loop that is. I try to recall things that has been paused sometime, and I recall that's the loop, and that's the one. We should reach there. I expect to reach there, and so 1, 2. Let me see. 1, 0, 1, 0, 2, 0, 1, 0, 2. Okay, that's the one. And we go to there. So target will be 2, 2 minus divide by 2. That would be 2. Yeah, target will be 2. So that's equal. That should equal, right? So let me see. Oh, we see. So things made 1 is 0. Let me copy that to the different window. And things, the made 1, let me see. Made 1 is 0, and the number size 1, 2 minus 1. 0 minus 1, that's fine. And made 2 is 0, so less than 1, that's okay. But numbers 1, 0 is 1 and 3, so that's else. So we just check made 1 plus 1. So made 1 will be 1. Okay, that's right. Made 1 will be 1. And we go back the loop again. So made 1, we go that here again. Yes, that's why we print out twice. I'm 1, I'm 1, 0, 1, 0, that's right. So 1, 0 should be true things. Should be true, okay, that should be true. Once that's true, we quit that while and go there. 1, 0 plus 2, that's 3. 3 now equals 3. 3 equals 3, that's right? Yes, okay. So we go there. Yeah, we go there and we will check things. Made 1 is 1. Made 2 is 0. Okay, so that's 2 plus 2 divided by 2 will go this branch. So that will be numbers 1 plus numbers 2, 0. So we should get right answer, right? Let me print out right here. So that's still okay. That's still the 1, numbers 1, numbers 1. Numbers 2, made 2, numbers 2, made 2, okay? Let me try run the test case again. Okay. Okay, so we're going to copy that, and run the code. Okay, that 2, 3. 2, 3 is fine. Why? 2, 3 plus 1. Okay. That's the wrong one we got here. Okay, we got double. Okay, I got right answer. Let me submit again. Excuse me. This takes output limit, so I'm going to that's fine, but I'm going to command this one out, and also command this one out. So looks like, hold on, that looks like problem. Let me copy this one, a few more before I run that again, and run. That's the infinity loop. So, we need to cover case. Okay, so, that's numbers 1. Great, so let's go made 1 plus 1. So 1, 1. Okay, so should we reach 0, right? And that's 2. Okay, that means we need to reach okay, let me count this. So for the very beginning 0, 0, okay, that's okay, that's 0, 0. And we go quit. That's true. That's true. Zero, 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 1, 0, 1. So we go this branch. Since that one 0, 0, so we go if else branch. That's made 1 plus 1. So we need to go. Why I don't see the I'm 1 equals 0, 1, 0. Why? Let me check the loop again. Okay, so for the 0, 0, so 0 less than 1, 0 less than 1, that's why we go this one. So if max that 0, 0 less equal min 0, 0, that's true. That's already okay. That's true. 0, 0 is true. 0, 0 is true, but 0, 0 is true, but 0, 0 plus 2 and 3 less than 3. Okay, less than 3. Okay. That part. That means we need go ahead. Okay. In that case, because that one doesn't go up, so we need. I'm thinking so. In that case, usually I could do start 1 equals made 1 plus 1 and start 2 equals made 2 plus 2. But I'm thinking which way is better. We do both plus 1 or we only do 1. Let me see 1. And minus 1. Minus 1. Okay. Let me check. Okay, that looks good. Let me test more. Wrong answer. That's now. That's now. Empty array. I'm thinking if I need to do corner case, I could handle in the main logic. Handle that in the main logic. Finish. That's 0. Okay, so that means 0, 0, 0, 0, all 0. So star equals 0. Oh, that's 0. So let's go out. Return. Okay, we don't return. In that case, in that case, 1 is now. 1 is now. We could still go. So I changed the while condition from AND to the OR condition. Okay, that's 0, 1, 0, 2. How that E1 is but anyway, 0, 0, 0, 0. One is null. Is there a correct test case? Let me see constraints. Okay, that's fine. Okay, that's fine. That's okay for the now. I'm thinking I try to handle the corner case in this while loop. So I expect start one numbers one. Array 1 has 0 now, and array 2, how that happen? 0, 1. 0, 1. Oh, that's minus 1. Okay, that's not good. Okay, let me see. Minus 1 is not good, so I'm thinking maybe we could yeah. And 1 equals numbers 1 size equals 0. F equals 0, that's equals 0. Then okay, that's 0, 0. So 0, 0, 0, 0. So we go to the 0, 0. Okay, 0, 0. We go to the 0, 0. Like so that else. So 0 made 1, 0 less than, no. Less than numbers. Okay, 0 less greater equal than minus 1, that's fine. And made 2, 0 less than 1, that's fine. So max so that's true, that's true. So first time that's 0, 0 will be true. So we go to this branch. That will be true, we go to this branch. So that's 0, 0 plus 2 equals 0 plus 1. Okay, that's the corner case is not good. It's not good handling the while loop. Hmm. So I would handle the side corner case if I had a while loop. So if numbers one size 1 equals 0, we just do let me try constant. It's constraint, so we have at least 1, so that means we have at least array not now. So we just handle the corner case here. If numbers one size 1 divided by 2 equals 0, then return double numbers 2 numbers size divided by 2 minus 1 plus numbers 2 the numbers divided by size divided by 2. Else double numbers 2 size divided by 2. Size 30 to 36, 30 to 36, copy. Okay, add 2, 1, 1, 1, 1, 1, 1, 1. Okay, that looks good. I know that looks ugly. I will try to optimize that later on. Okay, let me submit again. Wrong answer. 2, 2. How that's got, okay, the 2 is fine. So, first one is 0, 0 is fine. 0, 0 plus 2. Okay. Then we go 1, 1. 1, 1 is 1 is true. 1 is true, so it's right partition. So we just need, oh, that's the case. That means in any case we cannot do this. We cannot do this. We need searching. Each time we can only do once. Okay. That's really complicated. My logic. Numbers 1 made 1 plus 1 greater than numbers 2 made 2 made 2 plus 1. However, I handled made 1 plus 2 1 was not exceed. So in that case, which one is bigger? So the made 2 equals plus 1, okay, and made 2 else. Same thing happens here. So this time we check minus 1. Minus 1 if made 1 greater than made 2 element, we will move the bigger one. So we move here. Okay, let me copy this and try again. Run the code. Okay, that looks good. One step is right, so let's submit again. Charge. Okay, heap overflow. So that means 0, 0, that's fine. Let me open the print in the right partition sub function. Okay, that's because that's different test case. I got run. Let me copy this and run the code again. So that's 0, 0. 0, 0 is fine. Okay, 0, 0. Zero, zero. Okay, that's why. How Well, it seems that's another corner case. For example, for all my stuff, I will take the first element. There's no way we put their back there. I mean, in front of the zero index. Hmm. Yeah, yeah. Hmm. In that case, I'm thinking for the zero index, either I could use in the minus one here, it's fine to use minus one. Oh, on the very beginning, I'd better to using one index array to handle all this stuff. So zero means zero, means no element from that array. That will be making more sense. But so far, since I made that this step, I will use minus one as the zero. Okay. Oh, okay. We don't do this. Once, yes, that's the wrong one. So once we just check made one and made two. Okay, and here is minus one. Okay, zero means and equals minus one. Zero, zero, minus one, minus zero plus that zero. Okay, made e still equals zero. Hmm. I just calculate. So for the minus one, two indicates no element from that array. That's causing the calibration problem. Back to, I'm thinking maybe I could do back. Uh, I'm thinking if I need to change, convert everything back to the one index. That's frustrated. Let me think. Hmm. I also thinking a way if I could handle that case in the corner case above, but it looks not good. It look like I patched the logic too much. But anyway, let me Let me convert to the zero index array to the one index. Copy back to my favorite editor. Okay, so things. So O index pointer would point to one index array instead of zero index one. Okay, so that part is fine. And start will be 1. Okay, 1, 1. We start from 1 and end equals the size. That's fine. Let me think if I need to start 1. 1, 1. 1, 1 is fine. 1, 1 is fine. And return 0, that's okay. Okay, so -1 all time, that will be -1 to access any elements. So in that case, since that's zero index, we don't need a +2. Same here, we don't need a +2. And we don't need a -1 here, -1 here, -1 here. They did -1 here. Yeah. And we don't do +1 here. We're just using the made 1, made 2. And that's right. And we need -1 here, -1 here. And that will be fine. Okay, back to the right partition. Okay, so we check here. No -1, but there is -1. No +1. No +1. No +1. There is -1. There is -1. No -1. They need -1. They need -1. They need -1. Add -1. Add -1. Okay, that looks right. So back to here, things. If we move backward, we could and will equal 0. 0 means we merge 0 elements from a main array to the final array, so that would be the 0 index. Okay, target is 2. Okay. Hold on, target. Yeah. Okay, looks good. It seems that's fast to convert a zero index to. Let me copy all the stuff here. Let me double check. So once and then equals 0, and maybe for example and 1 equals 0, so we got made 1 plus 0 minus 1 0 minus 1, that's 1. Let's do 0, okay? This didn't handle the case for the 0 case. Okay, in that case 0, in that case, okay, is less. That means star one less than 0. We create a loop. It doesn't matter. We create a loop if create a loop. We create a loop. That means we have to using. Let me think. In that case, I designed to get made 1 equals minus 1. Made 1 equals minus 1. Then we go there. Let me try this way. So if and 1 less than 0, that means equals minus 1. We we just go to made 1, made 1 equals minus 1, else made 1 equals same things if and 2 equals minus 1, then made 2 equal minus 1, else. Star 1 equals and 1 equals minus 1. Okay. Star 2, I try to make sure the and loop keep going. Okay, so that's the one. So once made 1 minus 2, we go to the right partition. We just do here if made 1 less than 0, or made 2 less than 0, we just return true. Okay, so in that case that's right partition, and there will be the made 1. Okay, hold on, why with 0 index we need a 0. Okay, that's 0. Hold on, something wrong. Okay, that's 0, and the start is 0 and is 0 all time, so we don't need that one. Okay, we don't need that one. We don't need that one since that's index. Okay, I'm wrong. That's 0 0 0. Okay, that's all 0. Okay, if let me check. If made 1 equals 0, oh, 0, we return 2. Okay, so that's 0 index, so we don't need minus 1. No, I confused before that. So undeclared line 17, that will be the typo 17. 17, where is 20? Well, okay. One. Okay, 1 1 1 1. Let me copy this again to see what's wrong. Okay, 1 1 1 1. 1 1 1 1. 1 1 1 1 means 1 1 1 2. 1 1 means 3 2. 3 2. We go up. 1 2. That means 2 2. Okay. So since 1 1 is not right, so it's not right position, so we go this another tragedy. So for this while loop, any one not red prediction, I will do increase the main number I made two number to go up and get the longer target. We maybe do different counter words, but later on I will do later on. So that's why we got 1, 2, made 1, made 2, that's 3, and that's obviously made 1 plus made 2 is 3, is more than target is 1 plus 1 is more than 2. We go this branch. Yes, we go this branch. So the 1 minus 1, 0, 0, that means 3. Made 2 is 2, that's 1, 1, that's minus 2. So 3 greater than minus 1, so that means and 1 goes 1, so that's 0. And 1 goes 0, star goes 0, so made will be 0. 0, 0, why that's quit loop. We should go back, right? Hold on. Oh, that's 1, 0. Oh, okay, so since star is 1, okay, we still need logic here. Let me see. Okay, that's the one. And the one, okay, that's the same things. Okay, that's the same things. Okay. Add 1 equals 0. We just do start 1 equals and 1 equals made 1 equals 0. We change side array 1 to all 0 all the index to 0 4 clean up else. Same thing if and 2 equals 0, then star 2 equals and 2 equals made 2 equals 0. Okay, in that case, let me try run that again. Overflowed. Overflowed, overflowed, overflowed. So we go 1, 1, 1, 1, 1, 2, that's fine. And since that's 1, 0, so we go 0, 2, 0, 2, 0, 2 return true. So 0, 2, 0 plus 2, that's equal, right? So we just check. Oh, okay. Okay, so in that case, okay, so there'll be all numbers since 3. So the all numbers, that means we go If we go the other else, that's really complicated. So how we check if that means in this condition possible made 1 equals 0 or made 2 equals 0. So in that case, we just handle the 0 case right here. If made 1 equals 0, then return equals numbers 2 made 2 minus 1. Okay. Made 2 equals 0. Return 2. Made 2 1 minus 1. Else. Oh, that's really ugly. One, 2, 0, 2, 0, 2, 0, 2, return, return, return.